couple of years, so maybe you remember my talk or not. But I've been building a thing that we call Starfish, which is, the clicker doesn't work. So Starfish comes from Asterisk FS, so wildcard magical file system. And it's a work in progress. It doesn't do all the things that we're imagining quite yet. Am I on? Well, I'll click in the meanwhile. See that? Ta-da. So what I wanted to talk about today was my team got released, or is releasing our version 4 of our core database of our application. We got our first shipments out about 6 weeks ago, running into production. And I think we've done something that just hasn't been done before, so I thought I'd brag about it, and then you guys can kind of imagine what you'd use it for. So effectively what we've built is a really awesome sideband database for file systems. So we synchronize your ordinary everyday POSIX file systems to a database, and we just do that fast and furiously. We have a big goal in mind, which is to build an end-to-end lifecycle manager for your file systems. But I figured it was just easier to tell you about our magic trick or our mousetrap, and then you could think about exactly what the implications of it are. So basically, sync a file system to the database. That just means we're getting the data that comes back from a stat call. If you're on GPFS or some other file system that has additional metadata, we would capture that as well. So then imagine if you have this file system database and you can add tags or key value pairs to directories and files. Imagine if, like on directory metadata, the tags could inherit down the tree so that by tagging a directory, you could effectively tag its contents down below. Imagine if it kept version histories, so somebody renames a directory or renames a file or drags and drops directories, that the database reflects all of that. And then just imagine if we kind of totaled up everything there was to total up so it was queryable. So basically we know every directory, how many files of each type and user group, and we can total that up recursively up the tree. So some very simple questions like who used up all the storage since yesterday? You know, you come in the next morning and 100 terabytes was consumed. Where exactly did it go in the file system? So we just have some basically useful information like that. What would you use a database like this for? Well, you might make some reports off of it, and the reports are certainly very powerful because we've aggregated a lot of relevant data, and we have the tags that allow us to make even more specific reports. You might run scripts or jobs or batch processes, where normally you might do a find statement and then input that into some kind of a script. We built kind of a whole job or batch process manager that does that, but does it parallelized. You might want to do data migrations, like moving data from here to there, HSM-style workflows, backup restore-style workflows, check-in, check-outs, move files in and out of object stores where we have control over how we map those files and between file and object. You could imagine building a namespace portal where your users can basically log in and have a GUI interface that shows them where all their stuff is and allow them to do some basic interaction with their file collections. You might resolve broken links or lost files. Like imagine if you could just query the database instead of running a find statement across your couple billion files. And it might just be nice to do things like calculate a hash and just have that handy for duplicate file detection, content addressing, or fixity checking. So that's kind of the idea, is just a big old file system database. So what we did that's just cool is we made it scalable. Like my largest production client has 9 billion files in a single file system. We model that in a single server database, and the performance is just fine. We haven't pushed it much further than that, but we've got clients who are prepared to test us with up to 100 billion files, so we'll see how we do. We built agents for specific files like GPFS. We'll listen to DMAPI events and Luster. We'll play back the changelog. We get compared to Robinhood a lot. A lot of people have anticipated or expect that since Robinhood has a hard time with large scale that we would too. But we actually built a really parallelized data uploader and comparer. So at one of our sites, we're processing something like 30,000 file system events per second. So if you do some quick math, that's like 2 billion and change per day. And we're doing that pretty handily, again, on modest hardware. You don't have to build a huge database environment to do this. Our metadata persists as the users drag and drop things. And I think what that allows you to do in theory is you could associate metadata with files and directories as they're being created. And then that metadata could go along for the ride throughout the life cycle of the data. So from curation to publication and data reuse, that's kind of like a tagline that we've been pushing. So all of this is just done in a SQL database. It's Postgres under the hood, no secrets here. And I think that's part of what makes it really exciting is that it's just an incredibly versatile tool as well as the core of what we hope will be a really cool application that solves a lot of lifecycle management problems. So versioning, I just want to tout this a bit. I think I've never seen a system on the market, and anyone can correct me if I'm wrong, that actually tracks version histories. And I don't just mean of individual files, I mean of the directory tree. So we have something kind of time machine-like, where you could query the file system from yesterday or a couple hours ago or last month or last year, and we can show you what the whole shape of the tree was at that time. So that's great for backup and restore. We heard earlier how it's impossible to do backup and restore in a giant file system. But it really isn't. We just query our catalog, give me all files that meet the backup criteria, one of which is that the file wasn't already backed up, and make a copy of it and put it over there or over there or over there. So it's actually quite simple, and a recovery is just query the catalog from a point in time and put all those files back from there to here. Again, a simple operation. Finding missing files, we made something akin to a find statement that queries the database. It also allows you to include metadata in it. A virtual HSM where files can move out of the physical namespace but still be reflected in the database namespace. Checkpointing where you can just freeze a collection at a point in time. Now this isn't like atomic. It's not like while you're running data in flight, but you've got a collection at rest. You can basically say, yeah, I'm done with my research at this point, or I want to save this body of data. Easy to do. And then kind of the underpinnings for a provenance system. So the grand vision of all this, what we're trying to build is an application that services the needs of storage administrators who have all kinds of problems to solve, managing billions of files, content creators, whether they're scientists, engineers, artists, whatever industry you're in. There's some metadata and workflow operations that would be nice to automate. And then ultimately service the needs of preservation, publication, curation, et cetera, where effectively what you have is just a big old content management system that's really a federation of all your disparate storage devices. So a couple of quick bragging rights, and then I'm off the stage. 10-minute installation, really easy to install. And by the way, anyone who wants to play, I'd love to have you install it. Upgrades are invoked off the command line, single command, and it's pretty easy update. 8 billion files in our single largest single file collection. We have another client, I think I mentioned they have 45,000 file systems and over 100 billion files, so we'll cut our teeth there. 51 sites banging on the software as of this month. And one of our cool claims to fame was we did duplicate file checking. That is, we verified we detected duplicate files across a 5 petabyte file system at a rate of 1.7 petabytes a day. So in other words, from Monday to Friday, we found all the duplicates in over 1 billion plus files and 5 petabytes of capacity. And that was on a mid-range Isilon storage system. And then the punchline of that one, as you might imagine, 20% of those files were duplicates. And then it's a relatively simple job to remediate that. Ta-da, that's all I got.
Okay, very good. Okay, thank you, Jacob. We have time for one question, maybe two. The question? He might, yeah, go ahead. Yeah.
I thought we were taking the next speaker.
Yeah.
Yes, sir.
So you said you're using DMAPI for GPFS, and I see 30,000 creation or file system events per second. What happens if you fall behind? Do you block the file system, or do you just have to go scan later and catch up?
Oh, so when hold on a second.
Or you can use that mic up there, Jacob.
Yeah. So there are a handful of different bottlenecks in the process. So let's start with the assumption that your file system can give up those events. And we get events in one of two ways. We either scan or rescan a file system, or we listen for whatever information the file system can give us. So on a system like GPFS, we can take DMAPI events. We have not done methods at that scale coming off of the DMAPI. But what happens in DMAPI, if we get behind, they just queue up and then we drain the queue. Now, in theory, there could be a bottleneck somewhere that keeps us from ever draining it. But in our various stages of the process, we've been able to do as much as 30,000. So 30,000, again, if you do the math, that's like 2-point-something billion a day, which is even on a really, really big file system, that's corner case rather than typical.
Right.
Or would you agree? Is that?
I'm just wondering what happens when you get behind, because it seems inevitable that if you're creating 1 billion files, as
Yeah,
fast
so
as you
in,
can
in,
go.
in our world, if we stage the metadata from the file systems in intermediary files, and then we have a sort of a parallelizable uploader that slurps them up into the database. So if the database were down for any reason, our staging still works. And in GPFS, my understanding of it is that events will just accumulate for a really long time, and probably until something tips it over, but I don't know what.
Okay, thank you.
Yeah, my pleasure.
John Kachuk, you don't have any questions? Okay. All right. Thanks again, Jacob.
Yeah,
All
thank
right.
you.